Advancements in Computation and Language. Exploring AI's Language Mastery, cs.CL papers from July 29, 2025. Presented by AI Frontiers. Date, 2025-07-29. Topic, Innovations in NLP and LLMs. Field, Artificial Intelligence, Computation and Language. Imagine asking your AI for a vegan Indian recipe adaptation. It nails it perfectly with no bizarre errors. But here's the twist. Language models are now spotting and fixing their own mistakes like self-grading students. This episode dives into 32 papers from July 29, 2025, revealing AI's eerie self-improvement in handling human language. Buckle up for machines that think, adapt, and safeguard against flaws. Welcome to AI Frontiers, spotlighting the arXiv preprint server's cutting-edge AI research. Today, 32 papers from cs.CL on July 29, 2025 are examined, covering self-improving models to multilingual tools. The purpose is to explore how these innovations make AI more reliable, creative, and inclusive. Technical insights are blended with stories for tech enthusiasts, researchers, and curious minds. This is presented as a guided tour through AI's language puzzles. Computation and language is analogous to a bustling city where words serve as currency and computers build bridges between human thought and machine understanding. At its core, natural language processing, or NLP, teaches machines to parse, generate, and manipulate language, like giving robots intuition. Applications include sentiment analysis for detecting emotions, machine translation for breaking barriers, and chatbots powering assistance. Impact extends to enhancing education, healthcare, and accessibility, though challenges such as hallucinations and biases persist. Today's papers innovate in retrieval-augmented generation, or RAG, pulling external knowledge to ground responses, and safety. A key theme is improving retrieval-augmented generation, or RAG, like a detective sifting clues to avoid fabricating details. Examples include Guo et al. On DeepSieve for sieving noisy data and Luo et al. On Graph R1 for agentic retrieval. Metaphorically, models fetch facts on the fly, boosting accuracy in knowledge-intensive tasks. The technical concept of RAG integrates external databases with large language models, explained as combining memory with real-time lookups. This ties into reducing errors in multi-hop questions, like tracing climate impacts step by step. Focus is placed on making models empathetic yet reliable, defending against attacks without heavy compute. Examples include Ibrahim et al., who reveal that warmth can lead to sycophancy, and Vajula on biases in safety classification. Metaphorically, this balances kindness with accuracy, like training a helpful but honest advisor. The technical concept of adversarial defense removes principal components from inputs, simply put, filtering noise for robustness. This overlaps with themes by ensuring retrieved knowledge avoids harms. Reinforcement learning is integrated for self-feedback and niche adaptations like agriculture or humor. Examples include Van Niekerk et al. On self-feedback for calibration and Yan et al. On the AgriEval benchmark. Metaphorically, models refine skills by tasting their own outputs like a chef improving recipes. This covers multilingual tweaks and evaluations, pushing inclusive AI for low-resource languages. These themes build toward key findings on AI's autonomous evolution. Key findings are presented as breakthrough mini-stories redefining AI language. In the self-teaching tale, Van Niekerk et al. Show that large language models boost reasoning via internal confidence, like learning from self-doubt, cutting costs. In the biological detective story, Yu et al. Reveal that large language models outperform machine learning in pathogen prediction, averting outbreaks with metadata reasoning. in the culinary adventure, Hu et al. Enhance retrieval-augmented generation for diverse recipe adaptations, preserving cultural authenticity in outputs. In the memorization flip, Wu et al. Prove that large language models generalize from rote data semantically, enabling efficient knowledge injection but risking biases. In the multilingual wake-up, Li et al. Expose struggles with knowledge conflicts, urging robust retrieval-augmented generation to prevent hallucinations. One pivotal study is Guo et al.'s DeepSieve framework, which sieves information like a master librarian for precise retrieval-augmented generation. Motivation stems from fixing static large language model knowledge flaws for fresh queries in education or medicine. Challenges involve balancing modularity with efficiency, inspired by unreliable search frustrations. Metaphorically, it turns AI into a dynamic router, filtering noise for accurate responses. Next, methods and findings are explored. DeepSieve decomposes queries into sub-questions, routing to optimal sources like databases or APIs. Multi-stage distillation occurs, where the large language model scores and prunes irrelevant data for interpretability. It is built on agentic designs, autonomous actions, and tested on multi-hop question answering benchmarks versus vanilla retrieval-augmented generation. Strengths include modularity, allowing plugs into any large language model, and reducing hallucinations by deep grounding. Limitations involve reliance on reliable sources, as noisy inputs could still affect outcomes. Precision was boosted by double digits, cutting errors in diverse scenarios. Reasoning chains and trust were improved via traceable decisions. For example, 25% noise reduction in mixed data. Significance lies in a paradigm shift for reliable AI in law or journalism, minimizing misinformation. The human angle involves the team iterating on toy examples for transparency, drawing from personal search tool frustrations. This inspires hybrid systems. Risks include slower responses, but it paves the way for fact-checking AI. Future directions are envisioned with an analogy of AI language tech as a seedling sprouting into a mighty oak, drawing from its own soil through self-reliance via self-feedback. Hybrid retrieval-augmented generation with reinforcement learning is expected for robust agents, along with bias-tackling benchmarks in overlooked languages. Integrations with speech or vision are anticipated for holistic AI, and specialized models for health and agriculture with minimal data. Challenges like compute costs drive efficiency innovations, leading to ethical, accessible global communication. This blooms into transformed education and translations. Exciting times ahead. In recap, the journey covered self-teaching hooks to retrieval-augmented generation themes, key findings like Van Niekerk et al.'s calibration and DeepSieve's revolution. These papers showcase AI's leap in reliability and creativity across domains. Exploration of arXiv preprint server papers is encouraged, along with experimenting with models and sharing thoughts with #AIFrontiers. What excited listeners most? The conversation should continue. Curiosity is key. This synthesis was created using AI tools, including GPT Grok using model Grok 40709 for content generation. TTS synthesis was performed using OpenAI for audio narration and image generation using Google for visuals. The synthesized content underwent review by a human expert to ensure accuracy and coherence. It is important to acknowledge that some oversights may still exist. All references are provided for verification. Subscribe to our channel for more bleeding-edge AI insights straight from the arXiv preprint server. Channel title, AI Frontiers. Description, stay updated on innovations in AI. Don't miss out. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with 4 cutting-edge AI insights. Disclaimer, this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.